Hi, this is Renel Chesak, and I'm going over my final project, which is the Kaggle competition on the weather data. This is my main IPYNB notebook here, and inside of this file, we load and prepare data, we explore the data with visualizations, then we put the data in the 3D format for recurrent neural networks. We then refer you to the Kaggle kernels for the building and training of networks. Those are all included as PDFs, numbered 1 through 5 in the submission, and they're highlighted here. So these are all of the different trials that I ran in Kaggle kernels. Then we pull in the results from all of those and visualize them inside the main IPYNB notebook. Then we choose the top models and make predictions and compare them on a deeper level. Then we make predictions on the best model and put it in the format for the Kaggle competition. I want to point out that I have a file called functions.py. It's included. It has some handwritten functions in it. And we'll go over that in more detail later. In the beginning, we pull in the data and just do some basic data cleaning. Check for duplicate timestamps, check for null values, check for missing timestamps, and fill them with linear interpolation. Normalize the data. We use min-max scaler. And we also try using standard scaler in some variations. But you can see the Kaggle kernels for that information. We have a train, validation, and test set. Then we move on to data exploration. Here's the time plots of all of the features in the data set. And then in R, we graphed the correlation plot. And also the autocorrelation and cross-correlation plots. This is a explanation of the format for the recurrent neural network. And one of the files included in that functions.py that I wrote, these are my handwritten functions that we pull in, is the function that prepares the data. So it's just sampling from the original data frame to grab a single sample that it consists of each column representing a time step, and each row representing a time step and each column representing a feature as such. And then the rest of the functions in this file are for plotting, just to make things easier to use. So we prepare a couple of variations of the data. Some are just select columns that I thought were relevant. And then another sample is all the columns. Then we'll refer you to the Kaggle kernels for the building and training of networks. And the next step is to visualize the results from all those Kaggle kernels. In the beginning, you can see mean absolute error over the epochs for all the different trials. So there are a whole lot here. You can take a look at those yourself. But I looked through these and chose the best ones, and that's how I went through my process of finding models that worked better. And then another part of what we look at here is the true versus predicted values. So you can see those here. And the next step after the visualization is to make predictions with the top models. So we had 4 models that are described in the documentation, and they are represented here in this section. All columns, a shallow LSTM model, and min-max scaler. We pull in the model, which we saved from the Kaggle kernels, and use it to make some predictions on the test set. And we get pretty decent results. These are on the scale of temperature in degrees Celsius. So then the next one is all columns, deep LSTM and min-max scaler. We get another reasonable result here. Then we try select columns. We add interaction features, which is the select columns multiplied by each other, and they're included as features as well as the original columns. And we only use time step t-1 and a shallow LSTM model and min-max scaler. And this one Didn't do as well, but it's not unreasonable in mean absolute error. Then the last model that was predicting well was used all columns, a deep stateful LSTM network with a linear activation function on the final dense layer and min-max scalar. This model performed the best. It achieved 0.53 mean absolute error, and it makes really tight predictions. You can compare. So, then final step is to make predictions on the Kaggle dataset, and I'm pointing out here that I made predictions on the dataset without fixing the missing date times. Because previously all of this notebook was using data that had filled in all the missing dates. So for the Kaggle submission, we prepare a separate data set that includes missing time steps and make predictions and achieve still pretty good results, really good results. So we export those, put them in the right format for Kaggle submission, and that's the end of this file. Thank you.